Hello everyone, and welcome to Chapter 12, which is going to be dealing with trig. We are first going to be dealing with trig functions in right triangles. It is possible to deal with trig in non-right triangles, but we'll look at that later on in this chapter. So, you may remember the phrase, so katoa. That was used to help you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is going to come in very handy, because we have three new trig functions. We have cosecant, secant, and cotangent. Notice how the one that has cotangent goes with the tangent one, but these, the first letters are mismatched. The C from cosecant goes with a sine, which starts with an S. The S from secant goes with the cosine, so it's flip-flopped. Just be careful of that. There is no sort of phrase that goes with cosecant and secant and cotangent, but if you remember your sine, cosine, and tangent, all you have to do is flip your fraction and you're good to go. You're always going to list these as a ratio and never as a decimal. My tip for these in general is going to be make sure you label your hypotenuse and then label your other sides according to your angle. So if this is my angle, which we call theta, this is my opposite because it's opposite of my angle, and this is my adjacent. For some of these things you'll be able to do it without a calculator, but much of the actual solving of things you will definitely need a calculator, but a regular scientific is just fine if you don't have a graphing one handy. So, if I give you a right triangle, I might ask you to just give me the value of all 6 trigonometric functions. So I would do two things first. I would locate my angle and label all my sides. So this is my hypotenuse because it's across from the right angle. This is my opposite, and this is my adjacent. So now I'm going to set up where my answers are going to go. So I've got sine, cosine, tangent. Sine goes with cosecant. Now technically there should be a little a after all of these. I usually leave it out. It's technically improper, but if you leave it out, but you give me all the ratios according to the right angle, we'll be good. So, remember sine, so katoa, opposite of hypotenuse, so 20 over 25. 5 goes into both of those, so I will simplify. And then for cosecant, all I have to do is flip it around. Cosine, CAH, adjacent over hypotenuse, 15 over 25. 5 goes into both of those as well. For secant, just flip it. And then tangent, TOA. Opposite is 20. Adjacent's 15. And that's it for those. So label your angle, label your sides, get your answers all set up. So long as you always go in this kind of order, you'll kind of have that flow going for yourself. And they may also tell you similar idea problem, but not give you a diagram. So they're telling you in a right triangle, angle A is acute. That's important, but also if they leave it out, it's not necessary because we will always be doing these with the angles that are acute in our right triangle, not with our right angle. Because if you try to find the opposite side of a 90-degree angle, well, that's also your hypotenuse, so it doesn't work out. So, draw a triangle, label your angles. We've got hypotenuse, opposite, adjacent, tangent, O over A, so my opposite is 5, my adjacent's 3. You may be tempted to jump the gun and say, oh, 3, 4, 5. But remember, your hypotenuse has to be the longest side, So if you label 4 here, it's not your longest side. So we use Pythagorean theorem, which is a squared plus b squared equals c squared, so long as a and b are your legs. So c, or your hypotenuse, is square root of 34. That does not simplify, so we don't have to worry about it. Now, I need to find the value of my cosecant of a. Because it's not one of my 3 SOHCAHTOA ones, I need to think, alright, what's cosecant go with? Cosecant goes with sine. Sine is opposite of our hypotenuse. Therefore, I'm looking for the hypotenuse over my opposite. Hypotenuse is root 34. My opposite is 5, so my cosecant of a is root 34 over 5. You would have to rationalize if you had a radical in the denominator, but we do not here, so we don't have to worry about it. You may recall these from geometry. Special right triangles are 30/60/90s and 45/45/90s. If you remember them, good news, you don't have to re-memorize them, and some of these problems will be really easy and you won't really even have to show any work because you'll be able to use your ratios to figure out your answer. If you didn't remember them from geometry, you can either re-memorize them, or I'll show you tricks to kind of get around that using the unit circle and something called the trig hand drive later on. But you will have to use the trig functions in order to find certain angles. So like with this problem, if you know your 30/60/90, you can be like, alright, they gave me the 30, they gave me the s, so this must be s root 3, my answer is 5 root 3, round to the nearest tenth, and I'm done. Without it, I've got to write an equation. I've got my hypotenuse, this is my opposite, this is my adjacent. The function that deals with opposite and adjacent is tangent. So my tangent of 60 equals my opposite over adjacent. Multiply both sides by 5. And I do recommend that you write it so that the number is out in front of any sort of trig function, just so you don't have to remember to close your parenthesis. Now here is where the mode of your calculator is actually going to be important. Since this was 60 degrees, my calculator is currently in radians. That would give me a wrong answer. If you hit mode, scroll down to radian degrees, I want to make sure my calculator is in degrees, so I'll scroll over degree, hit enter, and then I can presume like normal. If you were using a regular scientific calculator, just make sure it says DEG somewhere in the corner of your display. If you need help with that, let me know. So I want 5 times the tangent of 60, which I get 8.66. Round to nearest tenth, 8.7. The reason I know that is reasonable versus if you were still in radians, you get like 1.6. This is a larger angle than this one is, so I know my answer has to be bigger than 5. If I kept my radians, my calculator in radians, which I would not want to do, but in case you forget, I get that 1.6, which doesn't seem reasonable because it's not bigger than 5. So that little thing that angles across from bigger sides are bigger can help you out. We will talk about radians, just not yet. So I've got a word problem here. I've got Joel standing 200 feet from the base of a building, and he wants to know how far it is from his eye to the top of the building. So I label what I've got. This is my adjacent. The two things I'm dealing with are my hypotenuse and my adjacent. The trig function that deals with adjacent and hypotenuse is cosine. So cosine of 76 is adjacent over hypotenuse. I want to get that d by itself, if you move these in one step, that's totally fine. So I've got d equals 200 over the cosine of 76. We want to plug that into our calculator. Notice how I did put my calculator back into degrees. So I've got 200 divided by the cosine of 76. We will deal with radians later. However, kind of cross that bridge when we get to it. If you put your calculator into degrees, unless you reset the RAM every time or you have to change out your batteries, it should stay in degrees. So I've got an answer of 826.7. That is definitely bigger than 200, so I at least know my answer is reasonable. Notice if I wanted to find the height of the building, I would have to use the opposite and adjacent, so my tangent function, plus the sixth the height, which ended up being irrelevant for the distance from his eye to the top. You can only take the sine, cosine, and tangent of actual angle measures. If you are missing an angle measure, you need to find the inverse sine, cosine, and tangent. So you hit second sine versus just typing in sine. So to find the angle measure of A, since all my sides are given to me, I've got my choices. I'm just going to go with the two that don't have a decimal. So the one that deals with opposite and hypotenuse is sine. So, since I do not have my angle, I'm going to do second sine for inverse sine, 9 over 17. And it's going to tell me the angle measure that has a sine of 9 over 17, which I get about 31.96, but since that rounds up to the nearest tenth, that is actually just 32. You did not have to use sine. You could have used the 14.4 and hypotenuse, whatever you wish. I wouldn't recommend using cosecant or secant since there aren't designated buttons for that on our calculator, but your call, I suppose. We also have these elevation and angles of depression problems, so it is best to draw yourself a diagram. So we've got a golfer. He's looking up 12 degrees. He is 36 yards lower than the hole is. And then we want to find the distance between the golfer and the hole from this camera on a blimp. So we're looking for this distance. Sometimes they can be funny worded like this. Other times they'll be more direct. I will try to give you ones that are more direct, but I did want you to see one that is a little bit weird. So, the horizontal distance itself can also be kind of a clue. So I'm looking at, I've got my hypotenuse here, opposite here, and this is my adjacent. So, my function that deals with opposite and adjacent is tangent, so tangent of 12 equals opposite 36 over adjacent. Because I have my angle, I do not have to worry about doing the inverse. So if I move things around, I've got d equals 36 over tangent of 12. And I have 169.4. We'll look at more of this the second day we talk about 12.1, but this is just to kind of get you an idea of remembering some of those things that we talked about back in geometry class with trigonometry. So I will see you then.